Chips are never down in India, and when chips are down across the world, you can bet on India. Now, these are the words by Prime Minister Narendra Modi in the recent Semicon India Conference 2024.
The chips are never down. When the chips are down, you can bet on India.
Semiconductors and semiconductor chips have really captured the imagination of people across the world, including in India. Indian government in the recent year has started many initiatives, policies and programs to make India a hub of semiconductor production in the world. So what are semiconductors and what are those semiconductor chips? Why nations across the world are so much obsessed about these semiconductor chips? What is the nature of the production and the supply chain of semiconductor? And what are the initiatives that the government of India is taking to make India a powerhouse of the semiconductor production? All these questions we are going to address in the current episode of Simplified. Hello everyone, myself Shubham Dattudi. Let's start from the very basic, that is, what are semiconductors? Now, on the basis of the flow of current, there are two kinds of materials that are identified. We have all studied in basic science that there are something called conductors from which current can flow easily, and then there are something called insulators which resist the flow of current. Now, in between both of this, there is something called semiconductors. Now, semiconductors are material like silicon or germanium, in which we can add some of the impurities which are technically called as dopant through a process called doping, and then can regulate the flow of current. Now, these dopant can be anything like phosphorus, antimony, indium, gallium, etc. So at the end of the day, semiconductors are nothing but those kind of material in which the flow of current can be regulated. And these basic semiconductors are the base of the semiconductor chips. That is the point of discussion today. Semiconductor chips, our whole life is revolving around them. The mobile in your hand, the laptops or the personal computer you use, the home appliances we are using daily, for example, TVs, ACs, refrigerator, all of them have some sort of semiconductor chips embedded in them. Semiconductor chips are very important even for the national security of the country. So our advanced weapon system, our missiles, drone, radars, all of them cannot work without semiconductor chips embedded in them. Our latest and newer technologies which will determine the economic progress of the 21st century, for example, artificial intelligence, machine learning, simulation, crypto mining, blockchain, all of them cannot be powered without the semiconductor chips in them. And semiconductor chips at the end of the day is going to determine the progress of economy and the technology in the 21st century. So we are very much sure that yes, they are very important in today's era. Now there are different flavors of these semiconductor chips. Now broadly they are defined on the basis of three criteria. Number one, on the basis of the flow of current. Second, on the basis of the functionality, means for which functions they have been designed. And third, on the basis of the advancement of the technology with which they are built. Now let's look into the first criteria. Now on the basis of the first criteria, on the basis of the flow of current, there are two kinds of chips. One, analog, in which current flow continuously, for example, the chips which we use in sensors. And second one are digital chips, in which the current is flowing in a binary form, that is in the form of 0 and 1. So most of the chips which we are using in our daily life are digital chips. Now on the basis of functionality, chip can be logic chip which are designed to perform a particular function. For example, chip which we are using in our video editing, video rendering, simulation, all these are GPU chips, and at the end of the day, GPU chips are logic chips. Then there are memory chips which are used to store information. Then there is ASIC, that is application specific integrated chip. For example, when you go to market and you scan for any payment, the barcode that you are scanning, which you are doing that with the use of ASIC, means these chips are very much application specific and they have been programmed to do one function repetitively. Then there is systems on chip, SoC. Now systems on chips are nothing but one chip in which the functions of many chips are embedded. For example, chips which we have used in a mobile phone, this is nothing but SoC, systems on chip. On the basis of the advancement of technology, chips are either divided on the basis of legacy or the advanced or cutting edge chips. Legacy chips are those which are of more than 28 nanometer, whereas advanced chip or cutting edge chip are those which are of less than 28 nanometer. Now, nanometer is a term which you will always listen or read about chips. Now, what is this nanometer? Now, for this, you have to just understand the basics about semiconductor chip. Semiconductor chip at the end of the day is nothing but an integrated circuit. So, a circuit is there in which various transistors are packed in a piece of semiconductor. Now, the power of the semiconductor chip will be determined by the number of transistors that chip is having. So, if you are able to pack large number of transistors in a smaller space, means your chip is more powerful, it will consume less power and work more efficiently. Now, nanometer at the end of the day is nothing but the size of these transistors only, which are packed in this chip. Now, we are talking about nanometer. Let me give you an example so that you are able to digest what nanometer is. So, the width of our hair is 80,000 to 1 lakh nanometer. The size of a red blood cell is 10,000 nanometer. And we are talking of chips in which you have transistors of less than or more than 28 nanometer. Now, let me give you one more interesting example. Now, recently iPhone 16 was launched. In iPhone 16, the most advanced chip of the iPhone, that is A18 chips, were used. A18 chips are with specification of 3 nanometer. Means the transistors that are used in this A18 chip are of less than 3 nanometer in size. And therefore, it contains more than 20 billion transistors in a very small chip that will be powering that iPhone 16. So, that is the kind of miniaturization, that is the kind of minute things we are talking about when we are talking about semiconductor chip and semiconductor chip technology. Now, this was the basic science regarding semiconductor, means what they are and where they are being used, and thirdly, what are the different categories of them. Now, let's look into the hard production of the semiconductor chips, means how the semiconductor chips are actually produced. The production of semiconductor starts from as basic as sand. The same sand which is used for the construction of house is also being acting as a base for the production of semiconductor chip. Now, a particular variety of sand is selected. This sand is purified and then silica is extracted from this sand. Now, this silica is itself purified for more than 99% purity, and then this silica is heated at a very high temperature. Then a silicon ingot is created out of it, that it is given a cylindrical shape, and then this silicon ingot is cut into very thin wafers. Now, these wafers will be acting as a base on which the whole circuit will be put for the semiconductor chip. Now, once these silicon wafers are cut, then the silicon wafers are coated with the photoresist material. These photoresist material are nothing but the light sensitive material. Now, once the photoresist material are coated on this silicon wafer, then a photo mask is used. Photo mask is nothing but a glass plate on which the electronic circuit design is put for the semiconductor chip. Now, a light is passed through a specialized machines which are nothing but a photolithographic machine using the photolithographic technology, and the light will be passing through this photo mask to this silicon wafer which is already coated with the photoresist material. Now, as the light passes through the photo mask to this silicon wafer coated with the photoresist material, whatever circuit pattern is there in this photo mask will exactly gets replicated into this silicon wafer. Now, this process is repeated multiple times, and therefore the transistors are getting packed at a vertical layer just like skyscrapers, but at a nanometer scale on this silicon wafer. Therefore, this silicon wafer at the end of the day is getting converted into a large electronic circuit having billions of transistors packed in it at a nanometer scale. Now, this silicon wafer with a large network of circuit is sent for the next stage of production. In the next stage of production, there are large number of chips that are cut out of this silicon wafer. Therefore, a single silicon wafer is acting as a base for a large number of semiconductor chips. Now, in the next stage of production, the assembly is done for all of this chip. They are tested for the accuracy and the efficacy. Then they are marked with some specification, and finally they are packaged and sent for integration into the electronic products. So the end cycle or the end production stage of this semiconductor production is therefore also called as assembly, testing, marking and packaging, that is ATMP. So we have seen that how complicated the production of semiconductor is. It is starting from as basic as sand and it is ending with the integration into the electronic products after going through the production stage and then the ATMP stage. Now initially and even today, there were many companies which were doing the whole production of the semiconductor in-house. That is, the design of the semiconductor, the production of the semiconductor and even the ATMP stage was done within the same facility. These companies are called IDMs, that is Integrated Design Manufacturer. Now the common name in the semiconductor space like Intel, like Samsung, like Micron are nothing but the IDMs of the world. Then over time the miniaturization has improved and even the specialization has gone up, and therefore few companies are specializing in a particular segment of the supply chain of the semiconductor. For example, there are companies which are just specializing in the design component of the semiconductor production. For example, they are just providing the design for the integrated circuit or semiconductor chip. Now these companies are nothing but are called fabless companies. For example, Nvidia, your Broadcom, Qualcomm, these are nothing but the fabless companies and specializing only in the design component of the semiconductor production. Now even the design company is taking help from some of the specialized company, because we have seen even the design is at nanometer scale. So we need improved softwares to produce this design for the semiconductor chip. So there is a new crop of companies that is specializing in just providing the software to the design company so that they can produce the design for the semiconductor chip. Now these companies are called EDA companies, that is Engineering Design Automation companies. You must have heard about the companies like Cadence, Synopsys. Now they are nothing but EDA companies helping the design companies to produce design for the semiconductor chip. Then once the design is ready, this design is going to the next stage of the production of semiconductor chip. Now this design is given to the manufacturing plant for the semiconductor. These manufacturing plant of the semiconductors are called fabrication plant or foundries. So there are companies which are just involved in the production of semiconductor chip by taking the help of the design companies or the fabless companies. Now they are like TSMC, Taiwan Semiconductor Manufacturing Company, which is the largest semiconductor fabrication plant in the world. Then you have Global Foundry in US, you have PSMC and UMC again from Taiwan, you have SMIC from China. So all of these companies are just specializing in the production of semiconductor chip. They are not designing their chip, but rather using the design which is being given to them from the design companies. Then after the production of semiconductor chip is done by these foundries or these fabrication plant, the semiconductor chip will move to the next stage of the supply chain. And that next stage of the supply chain is nothing but ATMP stage, that is assembly, testing, marking and packaging. Over time, there are specialized companies which are just dealing with this ATMP stage. Now these companies are called OSAT, that is OSAT, Outsourced Semiconductor Assembly and Testing Facilities. So we have seen that because of the specialization over time, the whole supply chain of the semiconductor has also improved. There are specialized companies which are operating at the design stage, which are nothing but the fabless. There are specialized companies which are operating at the manufacturing stage, which are nothing but the fabrication plants or foundries. And then there are specialized companies which are acting at the last stage of the semiconductor production, that is the ATMP stage, which is nothing but the OSAT facilities. Now the beauty of the semiconductor production is not the specialization that is there in each and every part of the supply chain. Rather, it is that each part of the supply chain is taking place in different continents. For example, designing is mostly taking place in the Western countries. The production and the ATMP is mostly taking place in the eastern part of the world. For example, in Southeast Asian nations. For example, Taiwan, in Vietnam, in Malaysia, in Japan and Korea. And at the end of the day, each of these are using the materials and the equipment from European countries. So let me give you one example. Now we were talking something about photolithography or photolithography machine. Now there is only one company in the world which is producing the photolithography machine for the advanced or cutting edge semiconductor chip, and that company is ASML, which is housed in Netherlands. Then in the photolithography technology itself, the glasses are produced only by a company in Germany. Then the material and equipment are coming from Japan and Korea, and the sand is coming from Australia. So the point is that the beauty is not in the specialization, beauty is in the disaggregated nature of the production of the semiconductor, which is requiring a very high level of coordination to finally get this wonder material called semiconductor chip. Now the point is, if the semiconductor production is such a specialized function, then why India wants to venture into this space? Now the reasons are very obvious. The first reason is that most of our semiconductor chips right now which we are using in our electronic products are imported. India is importing more than 95% of the semiconductor chips that are used here. Now India has an ambition of creating an electronic market of more than 500 billion by 2030. Now we cannot do that without creating in-house capacity to create semiconductor within India. The second reason is to create job. Now we know that the whole semiconductor supply chain can be divided into the three broad stages. The first, design, second, manufacturing, and the third one is ATMP. Now in the ATMP stage, the entry barriers are very low. So India can easily attract many companies to come here and start with at least ATMP function. Now it will not only help us to get integrated into the supply chain of the semiconductor production, but it will also help us to create job. It requires a very minimal level of skilling as compared to manufacturing or design. Now even if you talk about design, then most of the design houses across the world for semiconductor chips are using Indian engineers. More than 20% of the design talent across the world in the semiconductor space is Indian. So even that critical mass of talent is there in India. So we have strength in the ATMP, we have strength in design, and in manufacturing we are continuously working. So India is the best place right now for the production of semiconductor. Now if India is the right place for the production of semiconductor chip, then what all step government of India is taking to make it a better place? Now before delving into and discussing all those steps which the government of India is taking, let me tell you that this is not the first time government of India is having any sort of policies or programs for the production of semiconductor. This is not the first time we are venturing into space. Rather, we had our footprints into this space way back in 1970s. In 1976, we set up something called Semiconductor Complex Lab, that is SCL, in Mohali. At that time, the technology that we are using for the production of semiconductor chip was just one step behind the most advanced semiconductor chip used in the world. But something happened in late 80s, when in 1989, an unfortunate, or as some says, a mysterious fire broke out in SCL Mohali. And at that time, the whole hopes of India's semiconductor dream run were dashed. And now we are starting again. Now for this, today we are having programs like Semicon India program, a program of more than 10 billion US dollar, which is promising more than 50% of the project cost for any kind of semiconductor facility that is setting up in India. Now within this program, the nodal body is India's Semiconductor Mission, that is ISM, and it is providing incentive for almost all the stages of the semiconductor production supply chain. For example, the incentives are being provided for semiconductor fabrication plant, incentives are being provided for display fabrication plant, incentives are being provided for ATMP or OSAT facility, that is the last stage of the semiconductor production, and then the incentives are also for design of the semiconductor circuit. That is, there is a particular scheme within ISM, that is design linked incentives to provide incentive to the design companies. Then apart from this, then there is production linked incentive scheme, again encouraging the production of electronics and semiconductor. Then there is electronic development fund, which is used for funding of the research and innovation into the semiconductor space. There is 100% automatic route FDI that is open for electronic system and design manufacturing segment, that is ESDM segment. Now not only this, Government of India is also collaborating and partnering with the countries which have some importance in the semiconductor supply chain. For example, countries like Japan, countries like Korea, US, with which we have Initiative for Critical Emerging Technologies ICET, which have semiconductor within it. Then with Singapore, then even with Quad leaders, or signing agreements with Australia, or becoming a member of Mineral Security Partnership, so that we can get the rare earth which are required for semiconductor space. Now all of this is being done by keeping even the semiconductor industry in mind. Now at the end of the day, the bottom point is the initiatives are taken not only at the national level, but they are also being taken at the international or the regional or the group level across the world to make India a hub of the semiconductor production. Now these initiatives are not in vain, and there are many companies which are setting up their plants in India. Now there are companies like Micron, the company like Global Foundry, Israel-based Tower Group, then PSMC from Taiwan. Now all of these companies are either setting up their plants individually in India or by partnering with some domestic partner. For example, Tata's, Adani's, CG Power, L&T, all of these companies, domestic and international, are collaborating to make India a semiconductor powerhouse. Now the question is that, is India the only country in the world incentivizing the production of semiconductor? The answer is clear no. Now US in 2022 passed an act called CHIPS Act, creating helpful incentive for the production of Semiconductor and Service Act, in which more than 50 billion US dollar were promised for semiconductor industry. South Korea has passed K-CHIPS Act. Now under this, tax break are being provided to semiconductor industry. Japan has given an incentive of more than 2 billion US dollar. Taiwan is again supporting its semiconductor industry. And all of these four countries, that is US, South Korea, Japan and Taiwan, have created a whole group called CHIPS 4 or Fab 4 Alliance. Now this whole alliance is to keep its supply chain intact and to be protected from some other adverse countries like China. So not only the semiconductor production incentive is being provided by other countries also, but other countries are inching up their game a bit higher by controlling the supply chain of the semiconductor from adverse countries like China by creating various alliances. So semiconductor is something which is a buzzword not only domestically, it's a buzzword internationally right now. It is being played out geopolitically and geoeconomically also. We are living in the 21st century. That is the era of fourth industrial revolution. Technology is the new wealth of nations here. Semiconductor production is not simply about science. It's more than science. It's about deep intersection of science, economics and geopolitics. If we take fourth industrial revolution as a vehicle, and as many people say that data is the new oil for it, then semiconductor chips are the engine powering this vehicle. Semiconductor production and semiconductor supremacy has all the potential to be the real great game of the 21st century. Now this was all about the semiconductor and its production. We'll meet again with yet another interesting topic. Till then, goodbye, take care.